Okay. So let's draw our table. Let's complete the table using the method that we know. So let's take Q naught. What is the epsilon closure of Q naught? Itself and Q2. Yeah. Now, when you give 0 to Q naught, where should it go? It goes nowhere because it's not defined. Q2, when you give a 0, goes to Q3. Okay. And what is the e-closure of Q3? It's Q3 itself. So when you have Q naught, your answer, your resultant state will be Q3. Then do the same for Q naught. For the input 1, where do we go 1 Dunnama? I come to Q1. Here when I'm at Q2, I come to Q4. Yeah. So what's the e-closure itself? It's just the state itself. Yeah. So here I go to Q1, Q4. So Q0 is done. Now let's come to Q1. The e-closure of state Q1 is Q1 itself. There's nothing else. Okay. So where do I go when I get a 0 to Q1? It's not defined. What about if I get a 1? I come to Q naught. Yeah. E-closure of Q naught is Q naught, Q2. So here it's 5 and here it's Q naught, Q2. Then let's do the same for Q2, the state Q2. What's the epsilon closure? Q2. What happens when I give a 0? I go to Q3. If I give 1, I come to Q4. E closure is Q. So Q2 valadi I get Q3 and Q4. State Q3. Upon seeing 0, I go to Q. Upon seeing 1, I will go to not defined. Yeah. So this is not defined. This is Q2. Finally, Q4. E closure is itself. There's nobody else. When I see a 0, I will go to Q2. E closure is Q2. When I see a 1, it's not defined. So here I will get Q2 and here I will get 5. It's not defined. Okay. Right. Now by looking at this table, I can draw my NFA. Yeah. So in NFA, what do? I just put the states like in the epsilon NFA. There's no difference between, there's no difference in the states that I put. I have Q1, I have Q0. Who's going to be final and initial here? So the initial state in the previous one was Q naught, and then Q2 was the final state. But now since Q naught can automatically go to Q2 without an input symbol, Q naught also becomes a final state. At the same time, since Q naught can automatically go to Q2 without any symbol, Q2 also becomes an initial state. Okay, because both of them act like one state. So that should be both should be initial and both will be final as well. Then you have Q3 and you have Q4. Now what you have to do is mark the transitions. Okay, Q naught will go to Q1 when you see 1, then it will come back to Q note when you see an input 1. Likewise, looking at the results that you get in the table, you have to mark your transitions in the NFA. Yeah, so that is easy. We are going to look at another example here. We're not going to do this in the method that we did all this time. We are going to use another method to do this. I mean, similar method, but now we are going to use e-closures. Now this is NFA to DFS, a normal NFA, not an epsilon NFA. We are going to use e-closures, epsilon closures here as well. Okay, when I upload the slide set, the slide around 25 to 30, I have explained this method. So now, until you all feel that feedback form, what I have been doing is just doing what we know already. I have been filling the table. Okay, so this is how we learned in the morning how to do the DFA for this NFA. Okay, we do the transition table, and by looking at that, we draw the DFA. By looking at this table, we can draw the DFA. Okay, now how do we do this using the e-closures, using the epsilon closures? That's what we are going to look at now. Okay, now just like we did earlier, if we start from the zeroth state Q0, Q naught, and see what the e-closure of this state is, e-closure of Q naught, given the diagram, e-closure of Q naught is Q naught. Yeah, then check where it can go. Upon seeing a 0, it can go to Q0 or it can come to Q1. What is the null closure? Q naught, null closure Q1, because there are no any null symbols. Therefore, we just have only itself, the state itself as its null closure. Okay. Then upon seeing input 1, it can go to Q1 and the null closure is Q1 itself. Okay. Now what do? Now we know that e-closure of Q naught is Q naught, that we know. And when we give Q naught 0th what do you call alphabet symbol, and check the e-closure of that result like we did previously, then what do we get? We get Q naught and Q1. That is this result. Okay. Similarly, if we look at the other one, when I put Q naught 1, the resulting e-closure of that was this answer, which is Q1. Okay. Now using these, I'm going to draw the DFA up until that moment. Okay. So how do? I am at Q naught. Okay. When I get a 0, I will go to Q naught Q1. And when I get a 1, I will go to Q1. Okay. So that part is done for now. Now I have to go further. I have to look at I have to look at the next state now, Q1. Q1, when I give epsilon, when I take the E closure of Q1, it's Q1. When I give 0, where do I go? I will go to Q2. E closure will be Q2. If I give 1, again, I'm coming to Q2, so E closure will again be Q2. Okay, therefore I can say E closure of delta Q1 0 is Q2. Yeah. And if I do the same thing for 1, E closure delta Q1 1 is also going to be Q2. Using these two, I'm going to extend my diagram saying when at Q1, if I give 0 or 1, I come to state Q2. Okay. That part is done. Now this is remaining Q0, Q1. That state, I don't know where that state goes to, but using my E closures, which I found up until now, I can decide the states that it goes as well. How do I do that? If I combine, if I get the union of the answers that I got for Q0 and Q1, then I get the answers for this state. Okay, this is the same thing that we did earlier. Only thing is we do it without the tables and everything. So here what do I do? I get the E closure of delta Q naught Q1. That is the state I want now. What will happen if I give 0 to it? Okay, what will happen if I give 0 to Q1? If I give 0, this is what I get. Q1, if I give a 0, this is what I get. Now get the union of all of them. 0, 1, 2. Yeah. Q0, Q1, Q2. Similarly, do the same thing for the other one, delta Q naught Q1 1. What will I get? I should give symbol 1. So here it is Q1 and here the answer is Q2. Get the union of those two. Q1, Q2. Okay. Now looking at those two, I will extend my diagram further. I will say when I give a 0, I come to Q naught, Q1, Q2 state. And when I give a 1, I will come to Q1, Q2 state. Got it? Okay, thereafter, now who are the new states I got? New states are Q2, this and this. So I have to do the same thing for these people. Okay, so let's do for Q2 now. What is the E closure of Q2? Q2 itself. Bindu dunnahama. It's not defined. Okay, what will happen if I give 1? I stay at Q2. What is the E closure of Q2? Q2 itself. Okay, now I know that E closure of Q2 0 is not defined, and the E closure of Q2 1 is Q2 itself. By looking at these two answers, I can extend my diagram. Upon seeing a 0, it will go to the trap state. Upon seeing a 1, it will repeat on itself. Yeah. Then I have to go for these two, the other two, Q1 and this. Okay, right, I'll do it here. Q1, Q2, E closure of Q1, Q2 upon seeing symbol 0. What happens? Now I'll have to get the union of answers. Okay. So when I give 0 to Q1, where is it? 0 to Q1, I go to Q2. Yeah. And then when I give Q2 0, when I give 2 0, there's nowhere that I can go. Therefore, the answer here is Q2. Okay. Similarly, delta Q1, Q2, 1. What will happen if I give 1? When I'm at Q1, if I give a 1, my answer is Q2. When I'm at Q2, if I give 1, my answer is still Q2. Therefore, here again, the answer is Q2. Okay, I'll extend my diagram. Q1, Q2 goes to Q2 upon seeing either 0 or 1, anything. Right? Okay, that is also done. Now, finally, I have the remaining one, Q0, Q1, Q2. E closure, Q0, Q1, Q2 upon seeing 0. Where will I go if I see a 0? So I have to combine the answers I got for Q0, 1 and 2 all. Okay. So upon seeing a 0, Q0 went to this, Q1 went to this, Q2 went to the trap state. So altogether, I get the union, and my answer will be Q0, Q1, Q2. Okay. Then finally, the E closure of delta, the same state upon seeing the other alphabet symbol 1. What happens if I see 1? At Q0, if I see 1, I go to Q1. Here I go to Q2. Here I go to Q2. So the union will be Q1 and Q1 and Q2. Okay. Now look at those two final answers, and now let's extend the diagram. This state goes to itself on 0, and it will go to this on seeing 1. Okay, we did the same example in the morning using the tables like we discussed in the morning.